Hey, hi, and Assalamualaikum. My name, uh, Good evening, everyone, and welcome to my free online lesson. Okay, if my mic isn't clear or audio is cut off, just let me know in the chat section below. Okay, my name is Amir Safwan bin Ismail, a mechanical engineer in acadsystems, and today I'm going to show you how you can make a roller chain in Inventor Professional. Okay, just a heads up, uh, this lesson requires a intermediate level of modeling. So that's we will jump between uh, parts folder and also assembly folders. So if I'm going too fast, you can just let me know in the chat box below if you want to make me repeat the process or the steps, or if you have any questions. Okay, also another thing is we won't be getting any animation and also real-time reaction or interaction between the chain and the sprocket. Okay, I will show you a little demo. Over here, I have a chain and also a sprocket. Okay, if I were to move this chain in contact with the sprocket, we have this real-time reaction. But Inventor is not supposed to do this because the collision between these two will have a lot of computing, and also it will interrupt with the constraint. Okay, so as you can see, as I move this chain, the movement will not be smooth or it will be jagged. Okay, sometimes it will jump between the teeth, okay, or it will just stuck in position. Okay, Inventor can do this, but it is not supposed to. Okay, so for animation, we will require an angle of rotations. Okay, to animate this, we will use Inventor Studio, but we will need to consider the angle of rotations for our sprocket and also our chain. Okay, we will need to animate separately this sprocket and also this chain, so that requires a lot of time, and also the rendering also needs a lot of time. Okay, so that's why I only show you these modeling steps for our chain. Okay, moving on to the next section. Over here, we have roller chain components. So a chain consists of outer link, inner link, roller, bush, and a pin. Okay, so pitch, we have the distance. Okay, so the pitch is the distance between two holes. We have roller, diameter, and width. Then the roller, diameter, and width. Then we have inner link, diameter. Okay, so outer link and inner link each share the same width, which is 2.4 millimeters, and also we have pin diameter. Okay, next we have sprocket. As you guys know, a sprocket is a tooth, wheel, or gear used in machinery. It works with change to transfer the rotational motion, and also it commonly found in bicycles, motorcycles, and machinery. Okay, in Inventor, uh, there are this in Inventor, it has a roller chain feature or tools which will auto-generate the size and dimension of our sprocket. Okay, so means you do not need to manually design this sprocket teeth. Okay, this tool will auto-generate for us. Okay, over here, moving on to modeling steps. So as I mentioned before, we have roller chain generator over here. So the first modeling step is we want to set up this generator. Okay, I will explain this further in details further in the lesson. Okay, so the first step is we want to choose the chain size. Okay, so the chain size, which is 60, like this one over here, chain number 60. Okay, we want to select a plane to place our chain. Okay, number 3, we want to adjust the sprocket position by entering the coordinate so we can have the straight line of our sprocket. Okay, and then we need to insert the chain links as to this sketch. Okay, next, from the generator setup, we will take the 2D sketch over here. Okay, we will open this individual file. Okay, this 2D sketch is a guide or lineup position for the chain and our sprocket. Next, we will use rectangular pattern for the links position. As you can see in the picture over here, this point or dot on this line represents the link position. Okay, there are two sketches that we are going to use, which is inner link and the other one is outer link. And then we also want to use parameter to determine the distance between the link and also the starting point of our links. The next step is we need to model the roller and inner link, just like in this picture over here. These are the tools that we are going to use to model this link. Okay, and then we want to open a new assembly file to insert the 2D sketch and also the inner link. Okay, we will apply the constraint to corresponding planes for correct alignment. Okay, and then we want to assign the inner link to rectangular pattern. Okay, which means we insert one of the link and then we use rectangular pattern for the rest. Okay, and then we will model the pin and outer link, same step as the inner link before. Okay, again, these are the tools that we are going to use for modeling this link. Okay, then we want to insert inner link into the assembly like this. Okay, and then we apply constraints and also assign to the rectangular pattern. Okay, lastly, we will insert the sprocket into our assembly. Okay, and then we want to align the sprocket teeth to the linked socket just in the right picture over here. Okay, without further ado, let's hop on into Inventor Professional and let's start our modeling of our chain. Okay, just go ahead and create a new assembly file over here in millimeter unit. After that, head over to the design tab over here. Under power transmission ribbon over here, drop down this arrow. Over here, we want to click on roller chains. Okay, this window will pop up to ask us to save the assembly. Click on OK and choose your destination for the save file. For me, I will save into desktop and name this roller chain. Click on save. Okay, and now we have this roller chains generator set up. Okay, the first thing we are going to do is choose the roller chain size. Okay, for this lesson, I'm going to use this one, which is ASME B29.1M precision power transmission roller chains. Okay, you want to scroll down until you see the size of 60-1. Click on this button up here, accept current selection. And then we are going to click here to select the plane we are going to place our chain. Okay, drop down the origin folder over here and click on XY plane. As you can see, we can already see the outline or the draft of our chain. Okay, the first digit over here means uh, the size of our chain. Okay, the second digit or the digit in the middle over here means the number of chain strands. Okay, if I were to change this to 3, we can see we have 3 layers of chain. Okay, for this case, I'm going to use only one. Okay, and lastly, this 68 or the third digit over here, it means the number of chain links. Okay, if I adjust the position of this sprocket over here, you can see the value over here change also. Okay, now I'm going to set these options over here to fix position by coordinate. So by double clicking this arrow over here, I can adjust the X and Y coordinate of our second sprocket. Okay, to make it easy, I'm going to make both of these X and Y coordinate to 0. Okay, and for sprocket number 1, Y coordinate going to enter the value 0. For X, it can be any value you want. It depends on your preference and also your drawing. So for my case, I'm going to make it 362 millimeters apart. Okay, so now I need to have 62 number of chain links. Okay, lastly, I want to insert the chain as sketch. Okay, also, if you click on 3 dots over here, you can adjust the number of teeth you want your sprocket to be. So for example, if I have 12 teeth, okay, the size of the sprocket will adjust also. So in this case, we want to make it easy. I'm going to make it 24. Okay, make sure you enter as sketch. If I enter as solid, if I click OK, and this it will create additional parts for this assembly. Just click OK and accept. As you can see, we do not have the chain, but we have the outline or only the solid uh, solid trace over here. Okay, so it makes it hard for us to pinpoint exactly where the part is going. Okay, so that's why we're going to use the insert as sketch. Okay, just simply right click, edit using design accelerator, and insert chain as sketch. Click OK and accept. Okay, and now we have this 2D sketch of our chain. Okay, so this makes it easier to place the link on this 2D sketch over here. Okay, go ahead and click on save over here. Yes, to all and click OK. And then going to go ahead and click on open over here. And then locate our roller chain folder, design accelerator, and we want to open this part over here, which is roller chain 1. So I'm just going to rename this to inner line. Okay, so this line, this 2D sketch is for inner link. Okay, just open this one. Okay, so now I'm going to add a plane at this line over here. Okay, to do that, going to select offset from plane, drop down the origin folder over here, and click on XYZ plane. Okay, and then going to offset a little bit forward, something like 40. Okay, so that I can have proper starting position on the straight line over here. Then going to create a work point on this line over here. Okay, click on this work point of tools over here. Click on this plane and also click on this line over here, and then you can see the work plane we have made on this line over here. Then we will also want to make a new plane on this point over here. Okay, you can create a plane and use this option over here, which is normal to axis through point. Okay, go ahead and click on this point over here and this line over here. Now you have a plane which located on this point over here, normal to this line. Okay, go ahead and right click on this work plane over here and turn off its visibility. Okay, now we can start working with the starting point of our link. Okay, again, click on rectangular pattern over here, and then we are going to select this point over here and also work plane over here. Click on direction 1 and click on this path over here. Okay, we might want to add a new parameter here. I want to name this start point 1. Make it 5 millimeters. Check the key and export parameters, and then click done. Okay, so now I can add rectangular pattern. Select both the point and the plane over here. Direction, select the path curve, and then click on arrow button over here, list parameters, and then I can click on our start point. Okay, over here, click on drop down arrow. Orientation, we want to choose direction 1. At direction 1 over here, select our work point over here. This one, and click OK. And then we want to hide this work point and work plane at the big over here. Right click, turn off the visibility. And then we will work on this point over here. Okay, now click on rectangular pattern. Select just the point. Select just the point, and then direction 1, select our path. Okay, from spacing, we want to change to curve length. And then for quantity, we want to enter the number of link divided by 2. Okay, we divide it by 2 because the distance between the 2 dots is the distance between holes. Okay, so our chain have 2 holes, so that's why we want to divide it by 2. Okay, click on this drop down arrow. For orientation, click on direction 1. For direction 1 or start, here we want to click on this work point over here. Okay, as you can see, these points are distributed evenly along this line starting from our work point. Click OK. Don't forget to save. And for parameters, we want to change this back to 0. Okay, click on local update. And there we have our outline or positioning of our chain links. Okay, and then we are going to make another one of these for our outer link. Okay, you can do that by click on open over here, copy and paste this part over here. Okay, and I want to rename this file as outer line. Okay, go ahead and open this file. Okay, now going to tools bar over here. Click on measure, and we are going to measure the distance between the two dots. Okay, and this value we are going to copy by pressing Ctrl C. Click done, and then head over to parameters. Start point over here, we want to change into start point number 2 and paste the value that we copied earlier and divide it by 2. Okay, don't forget to click on local update on top over here. Okay, if I were to compare these two parts, we have this 2D sketch of our inner link, and 2D sketch of our outer link. Okay, so the distance between the two starting points are, the distance between two starting points offset by half of this distance. Okay. Then we want to create a new assembly file, and we want to insert our inner and outer line into this assembly file. Okay, click on place over here and insert our, go to our folder location and insert our inner line and outer line. Click open and click anywhere to place our 2D sketches. And now what I'm going to do is drop down the origin file of this assembly and also for this sketch. Okay, so what I'm going to do is I'm going to apply constraint for these sketches origins to our assembly file for our assembly origin. Okay, we want to use this flash constraint. Okay, under both of the origins here, XY plane to XY plane, click on apply, XZ plane to XZ, and then YZ plane to YZ. Okay, do the same step for the 2D sketch of outer line over here, XY to XY, XZ to XZ, and also YZ to YZ. Click apply, and there we have 2D sketches of the outline of our inner link and outer link. For now, I'm going to turn off the visibility for outer link. Okay, and then I'm going to create a new part file to model our inner link. Okay, standard in millimeter. Create a new sketch on XY plane over here. Make two circles with the dimension of 11.9 y diameter. And then click on dimension to adjust the distance between the two circles of our pitch, which is 19.05 millimeters. And then I'm going to extrude these two circles. Pick the direction and give the distance of extrusion of 12.7. Okay, this is our roller dimensions. Okay, on this surface over here, right click and create a new sketch. Okay, and then we are going to create two circles with the dimensions of 17.5. And then another two circle for this curve over here. It can be any number. You can do the same value as this, or we can make it 30. And then on the top here, we want to apply the tangent constraint to this big circle over here to our smaller circle. Okay, do the same for the bottom circle. And then we want to trim the part that we don't need. So in our case, this outer line over here and also this part over here. Then go ahead and to go to 3D model tab and click on extrude. We are going to extrude this part over here with 2.4 distance, 2.4 millimeter distance. Click OK, and then we are going to do the same for this part over here. Right click on this face, new sketch, and then instead of drawing a new circle, we can just use project geometry to project the part that we extrude earlier. Okay, 3D model, go to extrude, and then extrude this part over here. Click OK. And then we are going to add a new sketch over here to make the pin diameter. Okay, make a new circle over here with the diameter of 5.96. Okay, same for this side over here. Now I'm going to extrude cut through the section over here. Okay, click on our circles. Then over here, click on through all. Okay, as you can see, the extrusion is cut through all section over here. Then click OK. Okay, now we have our inner link. Now I'm going to add a new plane in the center over here to make it easier for us to constrain in the assembly. So in the 3D model tab over here, drop down the plane feature and click on mid plane between two planes. Okay, select this plane over here and also this plane over here. Okay, right click on the plane that we just made, create new sketch. On the bottom over here, we have slice graphics. Okay, if we turn this on, it will show us the cross-sectional area from the plane. Okay, we are going to create a new line from this center point over here to this center point. Then we are going to create a sketch point in the middle of the line. Click on finish. And then we are going to create a work point, okay, and click on the point that we have made earlier. Okay, and then we are going to create a normal to access through point to make a plane for this side over here. Okay, right click on this new plane, create new sketch, and then turn on slice graphics. Okay, from here, create a new circle with 5mm diameter. Then we want to make a patch from this circle. Okay, from 3D model tab, click on patch. Then click on the circle that we have made. Click apply and done. Okay, now we can hide visibility for this plane over here, this plane, and also this sketch. Okay, I'm going to save this part and name this outer link. Sorry, inner link. Okay, go to our assembly, click on place, and select our inner link over here. And then click anywhere to place our link. Then what we are going to do is we want to apply constraint to appropriately place our chain or our link. Okay, over here, click on constraint. We want to use this angle type and directed angle. Okay, select this face over here, and on the origin, assembly origin folder over here, click on XY. Click apply. Then we are going to use mate type of constraint. Click on this point over here and this point over here. Okay, and then last constraint, move this down a little. Okay, angle type, directed angle, select this face over here and also this face over here. Click apply. Okay, now we have the starting point of our chain links of our link, and now we want to make the rest of the links by using the pattern component over here. Select our link. Okay, drop down our 2D sketch, and then click on modeling and select the pattern that we have made. Okay, and there we have the rest of the links. Okay, from here we want to create a new part, which is outer link. Okay, make sure you turn this on, constraint sketch plane to selected face of plane. Okay, and click OK. Okay, now we want to select this plane over here. Create a new sketch, any feature over here, and click on XY plane. From here, you want to click on project geometry and project the diameter of pin over here, which is the smallest circle. Okay, go ahead and extrude this part. Select the two circle, and you want to click on 2. This means you extrude the circles to this face over here. Click OK, and there we have our pin diameter. Okay, now we want to create a new sketch on this face over here. You can make a new circle with the same radius as the inner link, or you want to use 15mm radius. If the units are in inches, you can just type in the millimeter units in beside the number over here. Okay, it will automatically convert from inches to millimeter. Okay, this one 30mm. Okay, and then we want to apply tangent constraint for this big circle over here to the smaller circle. And then you want to trim the excess part, which is this outer circle over here and also this part over here. Then you want to extrude this part here for 2.4mm distance. Same for this part over here. Right click on this face, new sketch. Okay, and project geometry for this shape over here, the part that we extruded, 3D model, and then we are going to extrude this part over here, and then click OK. Click return, and then we want to open this part over here. Right click. You can do that by right click and select open. Now right click on this face over here, create a new sketch. Click on project geometry, and we want to project this circle over here and also this circle over here. Okay, we want to extrude this part for 2mm. Click OK. Do the same for this face over here. Project geometry. Select these two circles and extrude. And then same for the inner link. We want to make the small patch of work plane. To do that, drop down the plane, mid plane between two planes. Select this plane over here and this plane over here. Right click on the plane, create a new sketch, then select Slice Graphics. Okay, click on line, and we are going to make a line between these two center of circle. Then we are going to place a point in the middle of the line. Click finish. Okay, make a work point on top of the sketch point that we have made. Create a plane, select normal to axis through point. Select the point, select the line, and then create a new sketch on this plane over here. Slash graphics, and we are going to make a circle with 5mm radius, millimeter diameter, and then make it a patch. Click apply, and now we can hide the visibility for this work plane and also this sketch. Okay, go to our assembly. Going to change the view so we can see more clearly. Okay, now we want to apply corresponding constraint to our outer link. Okay, if you cannot move this link, you can just turn off the adaptive option over here, and then you can start constraining. Okay, select constraint, type angle, and then select the directed angle. Select this face over here, and then select the XY plane over here. Click apply, and then we are going to change the type to mate. Select this work point over here, and then we want to turn on the visibility for 2D sketch for inner link over here. Okay, and then we can do the mate constraint for this line over here. and also this line over here. Okay, click apply. Then move this down a little. Oops. Okay, select the angle type, directed angle, select this plane over here, and then select this plane over here. Click apply, and then we want to use this pattern component over here to make the rest of the outer link. Okay, select our outer link, then drop down our 2D sketch for outer link, then click on modeling over here, click on this rectangular pattern over here, and then click on OK. And then we have completed the arrangements and the placement of our outer and inner link. And then we will proceed to for our sprocket. Okay, click on place and select one of the sprocket. Okay, so now I'm going to constrain this sprocket into the correct position by click on constraint, drop down the origin folder over here. Then going to use this flush constraint, XY plane for the sprocket to the XY plane of our assembly. Click apply and then mate constraint for our Z-axis of our sprocket and then Z-axis of our assembly. Okay, from here, you want to align the teeth into the sockets of the chain. Click on View tab. On the quarter section view over here, we want to use half section view. Okay, and then select on XY plane and click on right green tick over here. Then from here, we can properly align the teeth to our chain sockets. Okay, something like this, and then we can end our section view. Okay, for our next sprocket, we can just simply copy and paste by pressing Ctrl C, Ctrl V, and then we will apply the same constraint for this sprocket. Okay, drop down the origin folder, constraint, select flush, XY plane to XY plane, and then for mate, select Z axis to this axis over here. Click apply, and there we have our model of our chain roller. Okay, to clean up this chain over here, we do not need this plane anymore. We can just simply right click and turn off the visibility. And also you can turn off the visibility for this work point and boundary patch over here also. Okay, and now we have cleaner view of our 3D model chain. Okay. So these are the features that I use frequently in our modeling. Okay, so that is all that I can show you in modeling our chain roller. But before we end our session, I want to quickly navigate you guys through our acadsystems website. Okay, so over here in acadsystems.com, we have our missions and vision statements, latest Autodesk promotion and news, and also over here we have upcoming free online lesson. If you're interested in joining one of these, just simply click and then click on this Zoom meetings link over here. And then we also have our Acad System help desk. If you have any questions regarding Autodesk software issues or question, you can just simply create a new ticket as a guest and we will reply as soon as possible. Okay, and then we also have our Acad System YouTube channel if you're interested in watching tutorials of our Autodesk softwares, or you want to watch playlists of example, we have Inventor, we also have Civil 3D, and so on. You can just simply go and search Acad Systems in YouTube. Okay, so that's all for me. Thank you so much for your time, and sorry for dragging out the duration of our lesson. And that is all for me. Thank you so much for watching, and I will see you guys again later. Bye bye.